Welcome to Dynamic Foundry Group. Today we have Mr. Manish Kothari from Anand, Rhino Machines Anand, with us for our topic today is high pressure molding line. We all know high pressure molding line is a very upcoming new upgradation in the molding and foundry era. And because of high pressure molding line, we can say a lot of benefits like productivity, then accuracy, weight control, cost reduction, and many other things can be happen. This is what the normal perspective is there, and we are to today we can understand uh, what exactly is high pressure line, how it is working, what are the benefits, we can say drawbacks and benefits both with respect to high pressure line, how it can be selected, and what are the basic difference between high pressure line and alpha line. All these questions we already have in our minds, and that is why today we are going to see all these aspects of high pressure line. And for that, we welcome Mr. Manish Kothari from Rhino Machines Anand. He's a manufacturer of we can say kind of a machine which is also working as a high pressure line in the foundry. So welcome, Manish.
Namaste. Thank you so much. And Sandeep, it's always a pleasure to interact with you, and let us see if I can share whatever I have learned in my last 30 years of exposure to this technology. Uh, having visited Europe, seen this technology, installed this technology, commissioned. So there are different perspectives to this technology, and maybe we can see. And all these are coming from my views, whatever I have seen.
Yes.
There's nothing that this is the standard, but it's important that we start sharing what we know, and then probably we can also get a feedback of something which may be different from what I know.
Yes, sure. So today we are discussing this topic on the basis of question and answer. So let me ask the first question: what is the high pressure molding machine or high pressure molding line, and what are the difference between high pressure molding line and alpha line?
So this has been a very common question, and I also used to be curious about this. So what I gathered over so many years, I put them into. So I researched and found some references in a ASM handbook, and I mentioned the pages also, how they were classifying this mold. There is no specific guideline, or there is no specific any data on the basis of which we can say that this is high pressure, this is not high pressure. But broadly, from whatever was written in the ASM handbook, I could put them into three buckets. So, low pressure, which was earlier we call them that HPL1, and those machines which had Jolt and Squeeze separately operating. And there you could generate a force of specific squeeze pressure. It is important to understand that this classification is based on the force you are transmitting on 1 square meter of space of the mold, which is how I have come to understand. And based on the force generated by the pneumatic pressure in the Jolt and Squeeze machines, as we have seen for so many years, and still there are a lot of machines working in India today. They are able to do something around 1 to 1.5 kg per centimeter square, and the force is fixed. The specific pressure varies as per the size of the box. So many times I have seen a lot of people trying to adjust a larger size box on a smaller machine, but then they tend to lose on the specific pressure because the force of the machine is fixed. There's evolution, which we normally call as the ARPA, or in the CT series. So two organizations, BMD and BMM Western, to my memory and to my knowledge, in India, came up with this technology where the Jolt and Squeeze could operate simultaneously. So while it was jolting, there was a squeezing pressure also. This increased the force, and is more normally categorized into medium pressure, where you can get between 2 to 3 or sometimes even 4. So if you make a bigger box size on a smaller machine, for example, if you make a 550 by 550 box on a ARPA 450, which has got a nominally it is for 700 by 600, then you might be able to increase this pressure from specific pressure from 3 to 4 also. That is medium. And there's a very specific note which I'll share, which I got from this document, where the American Foundry Society accepted the definition of high pressure molding line as the pressure exerted on mold face equal or greater than 700 kPa. So 700 kPa is nearly 7 kg per centimeter square or 100 psi. And this was what they called as high pressure. And in this also, it somewhere it is written that it was achieved due to mostly hydraulic energy, but there are small machines where this can be done also with pneumatic. So this is, if you want to understand molding technology in green center process, we can put them into these 3 brackets, Sandeepji. So if you wish to look up, and if somebody has access to the ASM handbook or this notes, you may find this article somewhere, and you can find that. And so machines today, high pressures working from 7 kg to if you look at vertical flaskless, it may go to 12 to 14 kg per centimeter square. So all of them come under high pressure.
Okay. My next question is whether the high pressure lines are hydraulic or pneumatic.
The question whether it is hydraulic or pneumatic comes from the force which you can transmit. So in my experience, whatever I've seen, there's a very few machines or hardly any machines which are working on high pressure with pneumatic. One of the classic case is the Simtos FDNX. If you go and research that article, they are using pneumatic compressed air only for squeezing, but the mold size is small. The difference why we had to move to hydraulic is because in pneumatic you cannot use probably more than 6 kg or 7 kg pressure for transmission of energy, whereas in hydraulic you can go to 100, 150, 200 pressure kg per centimeter square. So if I were to take the example, let us say for a Jolt Squeeze machine, your bore diameter is 14 inch. So 14-inch diameter into 6 kg pressure will give an X force. But if I increase this pressure by, and so I have a certain box size, but if I want to double the pressure force, then I have to double the cylinder size, which makes it not possible using purely pneumatic squeeze force. So a majority, other than the small machines I mentioned, you'll find the machines working the hydraulic, the final squeezing, where you get the hardness or where you get the final squeeze pressure is by hydraulic. The initial compaction or pre-compaction in molding, which we call, is done from various different technologies, depending on each manufacturer has different technologies, whether it is aeration, it is by impulse, it is by impact molding, it can be by sand falling from a height, potential energy, so or by jolting, by vibration. So different techniques are applied by different manufacturers for pre-filling or pre-compaction. There is one technology I've heard which is impact molding, but I don't think it has been used much. I have not seen the machine working in India, which is using a compressed air release at a high flow. And so basically you're using high flow with a larger diameter pipe to transmit the force. So generally you'll find high pressure moldings machines working with hydraulic energy principally.
So you are saying that jolting can be different types, but whatever best squeezing pressure is there, it has been hydraulic in the high pressure
Yeah,
line, and both jolting and squeezing in the alpha line is by pneumatic.
yeah. So if you go back to the very basics of means I'll go back to science, Archimedes principle, where pressure into area is P1A1 is equal to P2A2. Okay. Now, if I have a box size of 1 meter by 1 meter, and I want to have a 10 kg per centimeter square specific squeeze pressure, so 100 centimeter by 100 centimeter, that means I need a 100-ton capacity force. For deliver a 100-ton capacity force by a 6 bar pressure, 6 kg per centimeter square pressure, you can imagine the size of the cylinder. So that's why the final squeezing, when you want high pressure, does not come through pneumatic.
My next question is, what are different types of high pressure lines and how you categorize it?
So there are different ways of categorizing the high pressure lines. First, of course, once we agree on the process that it is the process itself is based on the pressure which we exhibit, we are putting on a 1 centimeter square area. Once we understand that that is the process, then it comes to how well we are distributing the pressure and how well we are able to transmit have a uniformity of compaction throughout the mold. So it should not happen on the surface. I have got very good hardness, and in between I have got a porosity. That will come from the technique used for compaction. So this is one. So high pressure can have multiple factors which make a combination of any line. It can be with box, it can be without box. That is a way of handling the mold. It can be pure pneumatic or hydraulic or a combination. You can mold in a vertical direction like a Dizamatic or a Koyo machine, or you can mold horizontally, which is more conventional. The last element, production capacity, is where I think I've come across the maximum difference of opinion when it comes to high pressure, because most of the people I've met, they look at high pressure is related to automation, and so it should do 60 moles per hour, 100 moles per hour, 200 moles per hour, and we have been able to understand that productivity and process are two different elements in high pressure molding. You can achieve the same process with a low production of 10 moles per hour or 5 moles per hour also. So production capacity, high productivity machines are not necessarily high pressure. High productivity machines are more high pressure because the process is more adaptable to automation as compared to the old Jolt Squeeze technology. But if you go 30 years back and if you go back to, there were some plants in India also and in Europe also where even Jolt Squeeze machines were automated, and on an ARPA 450 there have been lines which have been producing 100 120 moles per hour. So automation is only enhancing the capability of the process, of how much output you can get, but it is not the process itself. So we need to understand this this, because the first three are more easily understandable. The last one is where I found the maximum questions arising.
So you can say it may be flaskless or it may be flask with a flask. It may be pneumatic, hydraulic, on horizontal and vertical parted line. So you can
each
define. Every line has, or every machine has its own.
Yes. Every machine has its own characteristics, own benefits, its own. So so we can only pick a few of those classical benefits.
Which is the most popular in the world and in India?
What the process?
We can say which type of high pressure line is most popular. There are numbers. We can say a number game with respect to number.
So the more popular is horizontal flask molding, which is a much earlier technology. It has been there for many years. This is from my experience, because flaskless molding perhaps, so compared, means we can go back a step back. A Jolt Squeeze machine also had two versions, if you remember. There was a snap flask and there was a flask molding. Snap flask was making the mold in a jacket and then making it flaskless. So both technologies existed even in Jolt Squeeze machine. The advantages and disadvantages were different. But if we look at how the technology has evolved, it started from the process first, and then went into how to optimize the total cost, how to optimize the total productivity. But Jolt Squeeze machine per se were you are molding in a box first. So flask molding became more common right from then. And from my experience, the most flexible process after ARPA machine. ARPA machine has more flexibility as compared to a Jolt Squeeze machine has a more flexibility as compared to high pressure. But when it comes to flexibility within the high pressure family, then the flask molding is perhaps the most flexible out of all the machines, where you can make any kind of product, any variant. You can make a short run, you can make a long run, you can make heavily cored, you can make you can put risers, you can put multiple venting. So anything and everything which you are doing in Jolt Squeeze as a process, or we were having the flexibility, can be done in flask molding, is what I have seen. And that's why perhaps it is the more popular as a process solution.
Yeah, tell me.
Yeah. Whereas flaskless has a very distinct advantage where you are producing and closing in the same machine. So your casting shift or your mismatch is limited to the condition of the machine and its guides or its tolerances, how well you are maintaining. So that advantage comes in flaskless. You can have a higher productivity because you can have lesser machines, but there may be some differences which flaskless is not able to, some castings which flaskless is not able to take up.
Yeah, I want to say the same question regarding the one of the basic advantage the people thinks in the high pressure line is it to control the shifting of the casting. That mismatch is guaranteed.
Yes.
So in flask and flaskless, what is the scenario? Which is the best technology to achieve, we can say, good dimensional accuracy and lesser mismatch?
So from my study, the vertical flaskless, I think, has the lowest mismatch because of its characteristic of molding, where you are having cake after cake going in one. As long as you maintain your liners and your all the wear parts in good condition, you may get the I think within 0.25 mm is what I've heard it, or 0.3 mm is what you can get in vertical flaskless. That is the lowest when it comes to mismatch on an average. Then comes horizontal flaskless, which can be similar or little more. And then comes the flask, because in the flask molding, you are not using the same references for molding and closing. That means you have multiple tolerances involved. Whereas in flaskless, you have only one tolerance involved, which is inside the machine. But in flask molding also, you can reach up to 0.5 on an average with a good well-maintained system, which normally in Jolt Squeeze machine, a good machine can maintain 0.6, 0.7, but generally the machines have much more tolerances than much more mismatch than high pressure molding.
What is the weight control factor? The how it is been controlled in high pressure line, because it is another very important aspect considered as a high pressure line.
Hmm.
What are the
So
reasons?
ultimately, the when we look at why high pressure molding lines came in, is coming from this basic advantage where ultimately what happens when your mold is harder, your mold dilation is less. When your mold dilation is less, your dimensional control is better. When your dimensional control is better, your weight consistency is better. So still a lot of people say, no, my weight, average weight is correct. But you have to understand that there's an average which you can work with this range of weight, and there's an average which you can work with this range of weight. So if your CPK, your graph, your weight variation, standard deviation of weight variation in high pressure is much lesser than Jolt Squeeze machines. So you good process control can bring your weight into maybe 1%, 2% control, where in Jolt Squeeze I have seen castings go from 2% to 10% weight variation. Because so one, there could be multiple factors, but the molding strength, the hardness and the compaction of the mold being much better, 4 to 5 times more stronger, as a more force has been applied to this mold. The variation is lesser, and therefore probably the weight variation is also lesser. And this there is one more factor which adds to this, is with high pressure, because you're having a higher force for compaction or squeezing, you are able to use a higher green compressive strength in the molding process. In Jolt Squeeze, it is very difficult to use a GCS of, let's say, 1600, 1700 or 2000 GCS, which not generally in high pressure you are using around 1500 to 1800 GCS. So the mold, one, you are getting an advantage of the squeezing. Second, you are getting the advantage of a much higher strength of sand, which can withstand the mold dilation. And that is what is impacting the weight control.
Regarding the sand properties, you take GCS. Apart from GCS, any other variation or any other changes are required for the high pressure? The sand for the high pressure and alpha line can be different. If somebody has the same infrastructure, they have a high pressure and alpha, whether they can use same sand for the both, or they have to make differentiate.
So that's a very interesting and good question, because we have references of these cases in our journey over the last 15-20 years. And while we can say the sand is similar, but it is not the same, that means you may have to compromise on one of the molding processes somewhere. If you are using a high compressive strength, higher GCS, the moldability in the Jolt Squeeze machine goes down, and you can start having problems. So I have seen that because of that reason, those who had a common sand plant for the high pressure and the Jolt Squeeze, they were forced to run at a 1300, 1400 GCS. So they could not get the full benefit of the high pressure molding line. This is one part, that is as a system sand. So one is a system sand, how you maintain. And the second part is when you are working at a on high pressure, you are working with lower moisture, because your squeezing and everything is much better than Jolt Squeeze, and you need a higher flowability also. In Jolt Squeeze, the moisture levels are higher, which can be adapted by your process control. If you have an online sand controller, you can manage 2 types of sand, but manually it is of course very difficult to manage 2 types of sand. So if you're running both in one line, it is a process and production challenge.
In high pressure line, whether we need skilled manpower on the machine side and at the maintenance side, both.
So see, skilled manpower was required even for Jolt Squeeze machine. every technology has its learning curve. When Jolt Squeeze machines came to India, probably 30, 40, 50 years ago, that time there may have been a shortage of those skilled manpower. But as the popularity increased, you got skilled manpower. But Jolt Squeeze machines required skill on the process and the production also. Whereas in high pressure, the skill need has shifted to more generic skill, which is of maintaining the machine. So the shift of skill has in two directions. One, you need higher skill in understanding the process and managing the process. So it's more of a technology skill. And the second set of skill set which you need is on the operations and management and more discipline. So from Jolt Squeeze to high pressure, there's a shift in the skill set. But over a period of time, every technology develops its own skilled workforce. In India, still we are not having sufficient manpower for high pressure molding yet. There's always a shortage of good people who can manage and maintain high pressure molding machines or molding lines.
How much manpower is required? How difference in with respect to alpha line and high pressure line? Is a reduction in the manpower or is the same one? And how it affects the overall cost impact on the we can say costing of the foundry? Whether it has some we can say substantial impact on the costing or not? Because
So
as
generally,
I will say, high pressure has a very high investment and alpha is comparatively low investment. So whether it justified that investment with respect to manpower cost, labor cost, operating cost, maintenance cost.
See, there are to make an evaluation of the viability has multiple dimensions. So let us talk of the first dimension. The first dimension about manpower. Yes, there'll be 30 to 40% reduction in number of people working for the same production between Jolt Squeeze and high pressure molding line. Okay, so that part has been seen. Now the extent of reduction will also depend on the extent of automation we put in. The economics have three factors in to my mind. One is manpower. Second, the major factor where people are able to justify the investment is not from manpower, but from the weight consistency, dimensional stability factor. Because if you consider 1% or 2% reduction in your metal saving, that is far more than the cost of manpower. Having said that, the machines which we have been making, what we understood that since we don't have very high skilled manpower, we have looked at simplifying the technology to the extent possible. And today, a normal maintenance person who was working on Jolt Squeeze machine can also work with a standalone high pressure molding machine. So there is the increase in cost of per person, the total cost of manpower is not as much. So you don't need very highly skilled manpower to run a high pressure molding machine as we normally perceive. You need highly skilled manpower when you're running a fully automatic machine, because you need people who can manage that automation and automatic system.
So you can say cost can be justified with respect to reduction in cost of labor with respect to productivity.
Yes, there is definitely some. See, again multiple aspects. One is the direct reduction in cost of labor. Second is the loss of opportunity when you are not able to produce. As a business person, you might look at multiple dimensions when you take a decision that if I have an order for 500 tons per month and I have not enough manpower and I am producing only 250 tons per month. So even if my investment is 30% lower, it is not going to help me in long term. I may start losing business. So we have to consider those risks also when we are talking of investment. So selection of the process is a complex process, which from what It is not a 1, 2, 3 answer in any case.
We talk about shifting earlier, and we say that in flaskless it is with little less as compared to flask type of machines. So in alpha line, we normally see pin bush inspection of the box, and the match plate plays an important role, and a lot of issues will address in the alpha line. So is that same criteria we can see in the flask high pressure line? And
So
what are the areas where flaskless also have some issues like shifting? So what are the precautions, or what are the areas we have to focus on?
So let us talk first of the flask molding, box molding. Though we use pin bush, since there is no vibration, no jolting, the loosening of the bush or the fixation of the bush is not a big issue. And you can use very high hardness 60 RC bushes in the high pressure molding and the pins also. So compared to Jolt Squeeze, the life of the pin bush is much longer than uh, high pressure, in high pressure. And second, because there is no jolting, there is no forced wear and tear, there's no forced movement between the box and the pin, which also does not reduce the. So the checking in both cases would be required of the pin and bush, but the frequency would be much longer. The distance time between two checks would increase, and the life cycle of the parts is also longer. When it comes to flaskless, it is the guides. Every machine has a different design, so I can't talk. I have not manufactured or I have not seen the machine from inside, but there are guide rails in the machine in horizontal flaskless. If you don't, if you're not careful in inspecting them and ensuring that they're perfectly aligned, then you can start having mismatch, which you cannot, you'll know only after, let us say, 50, 100 molds have been produced. The vertical flaskless also has this a very small shift in the vertical face can cause leakages and casting shift. So every process, there are some minute details which every machine manufacturer would definitely advise on what care you should need to take. Compared to Jolt Squeeze, yes, all these high pressure molding processes have much better control, easier control, and dependency on people maintaining the machine to get the casting quality is reduced because the process is shifted, control is shifted more to the machine.
In alpha line, normally we see the sand cord is required after the casting. It's around 50 mm. So is there any change in the high pressure, or it has been reduced, or it required the same sand cord, sand wall for the we can say avoid the leakages of the metal?
So the sand wall in case of flask molding is lesser as compared to flaskless. That is, so flaskless, I think you need 40 to 50 millimeter sand wall. While in flaskless, we have made castings with 25 mm sand wall also.
So with the box,
With the
can
box,
be 25 to 30
with the
mm.
box, you can 25,
And
30.
with flaskless, it may be around 50 mm.
Yeah, because in
Because
flaskless, you don't have
there
that.
is no support from outside. My next question is is there any limitation for downscrew in the high pressure line? Because this is another very important aspect that most of the people are worried when they are talking about the high pressure. The
In
downscrew
flask,
location is the biggest challenge.
yeah, in flask molding, there is no limitation. You can adjust anywhere in the box because it has, and the downscrew is made outside the machine, or there are some innovative ways of putting a pouring cup while you are molding, and there is no, you don't need a fixed position where you can cut the downscrew. While in flaskless, yes, I've seen most of the lines have limitations that you can make a screw only in this area, and sometimes you have only 3 positions where you can put a down screw. In vertical flaskless, of course, you have even lesser place to move around with the down screw.
So it will definitely impact your yield and number of more good
Yes.
casting per box, all these
So,
aspects.
so we have one customer in Jalandhar who's making very light castings. So he has 3 down screws in one box. That is possible in high pressure box molding. So he pours one casting, second casting, third casting, all in the same box because it's very light. And to get maximum utilization of the area, it is possible, which may not be possible in flaskless molding. That kind of flexibilities are not in flaskless as compared to flask molding. Flask molding down screw is as flexible as Jolt Squeeze lines.
We talk about the flexibility. So flexibility regards to core setting is also another aspect when we talk about the especially flaskless molding line. So is there a challenge, or it can be overcome with the certain added we can say facilities given in the machine?
See, in flask molding, you're very similar to Jolt Squeeze molding. So because both are flask molding, so you don't have any limitations with respect to core setting. You can have as many stations. You can have an auto core setter outside the molding process. So it is not reducing. So you are very right. One of the very common questions we get: how many molds with core and how many molds without core? Is a very common question.
Yes.
This is applicable for flaskless molding, not for flask molding. That's a very important differentiation, because flask molding, we are not putting the core inside the machine. It is only flaskless where, because it is part of the cycle, there are different configurations. There is one supplier where your half box comes outside, you can place the core and then it can go inside. So it is parallel to the molding cycle. There is a vertical flaskless where you have the masking system where you can put your mask cores outside and it can go and put it right inside the machine, because most of the flaskless molding lines are high production machines, 100 molds per hour to 500 molds per hour, where you cannot think of putting the core inside the mold in the machine. So there are solutions where core masking solutions have been made, and but of course flaskless will have its limitation on what size of core you can put, and that's why I said flexibility of making castings in flask molding is always more than flaskless. So if you want to make, for example, a tractor casting or a differential casting, to put such a big core and assembly of cores inside a flaskless is a very humongous task, because it's not a small core.
Similarly, whether placing of chills and sleeve also has the same aspect.
Yes, the flask molding has an advantage where you can place the chills within in the pattern itself while molding, or you can there's a flexibility of putting the pouring cup, this exothermic sleeve. All those flexibilities are available in flaskless molding, which I think are difficult in flask. They are available in flask molding, which I think are difficult in flaskless molding.
So it is very difficult to put a chill or sleeve with a high pressure line with a flaskless.
Sleeve, I think it is. I have not come across people putting sleeve in a flaskless. Chill, possibly, it may be possible. I'm not so sure it is possible in all the machines or not.
And what about venting? Because venting is a very important aspect in the molding to make a good quality of casting. So venting is we can drill down the mold and all these things. So whether these facilities are available in the flaskless and both, or it is not available in the flaskless.
Venting is not available in flaskless because everything is inside the machine, so you can't go inside. In flask molding, you can do as many vents, drills, and holes as you want, because it is outside the machine.
So you are taking saying that inside the machine, outside the machine. So what it really makes the safety of operator, safety of pattern, and safety, overall safety with respect to, we can say, machine with a flask and without flask, which is the safer one.
So both the machines come with their safety systems, whether it is flask or flaskless. Both have their safety systems. The safety, unless you override the safety and you bypass something. Whereas if you compare again, go back to the Jolt Squeeze machine, there it is much more unsafe because if there is no the person is there when the squeezing is happening, and you can have your fingers go between the mold and the squeezing plate, which is avoided. There are in the both the high pressure processes, flask or flaskless.
Okay. So we have a lot of debate on flask and flaskless. So when we can select flask or flaskless, is there any criteria? And what are the benefits? We are talking more about flaskless is having some challenges as compared to flask high pressure line. So when we people go for the flaskless by overcoming this flask issue, what are the areas or what are the criteria they decide on which the selection of machine can be decided?
So I can't give answers to everything, but what I know of certain products, which when customers say that we want to produce this, for example, if you want to produce grinding media balls, so things which are without a core, and you have a high volume requirement. So up to a certain size, let us say up to 60 mm diameter or 50 mm diameter, flaskless is a much better process than flask molding because of its volume and better shift control. But if you want to produce a gearbox housing, then you cannot go for flaskless. So vertical flaskless, in particular, if you are not very heavily cored, there's a customer who's producing ravelin inserts in this. Recently, I've seen manual covers being produced in Eastern India because the machines came from China, where the castings are not very less cored. Vertical flaskless could be a much better option. Horizontal flaskless has high productivity and lesser casting shift. So if you're when you're selecting, if your product range does not have the need for venting, it does not have those issues of pouring cup or yield, then probably a horizontal flaskless may find a better suitability compared to flask molding. So then there is sand to metal ratio, how much metal you can pour. So then you get into small areas of process limitations, and certain flaskless machines, you have a shadow of shooting area. So when you're shooting, if in between there's some higher pattern part and your sand is coming from here, you should not have a shadow area. So selection of a machine, particularly in flask and flaskless, requires a good understanding of what you're going to produce before you take a decision to purchase a flaskless machine. Flask machine, as I said, is like buying a Jolt Squeeze machine, except that you are only upgrading your process to a better process.
So we can say a foundry person come to you as a machine manufacturer to buy a machine, and they have to select a machine. You have some criteria like what is their productivity, is it high or low, is it code or non-code, what is the accuracy requirement. Then one more thing you talk about is the you can say the weight control, how much weight control is required. So all these aspects can decide. So with a non-core with high productivity and more accuracy, you can go for a flaskless line. Otherwise, you can go to the flask line.
Flask line.
Yeah.
So it requires a lot of multi-dimensional thinking and understanding of what you. It comes from what you want to produce.
Before selection of machine, you should have a proper idea what kind of product mix you have.
Or you should
without idea of that, you cannot select the machine.
No, I would not say you cannot. I would say you should not. Not cannot. I cannot tell somebody what not to do, but I
Yeah.
would recommend that two things. One, you come with something where you know you can sell, and after you have made that, let us say, understanding, okay, I can do this flaskless. Also start to understand that what are the limitations and which kind of market you should be looking in the future,
Yeah.
because you should not think that I have high pressure so I can sell everything. So
Market survey is important.
understanding two things. One, what is it that I can sell today and what is the best process? And after having selected the process, what am I not going to produce in this? I should
Yeah.
know.
So a person having a vertical high pressure line, having we can say less sand to metal ratio, heavily poured item, he will fail drastically because the process is not meant for that particular product range. Correct?
See, let me, so the moment you get into very high accurate activities, your core has to also be as accurate as your molding. So if you look at certain castings, they were using oil sand cores, or the people would be rubbing cores on the line. Though all those activities will go out of the window. So it is not only the molding process. You have to look at the entire process. You have to look at your metal balance. With vertical flaskless, you have maybe 10 to 12 molds in which you have to pour. You cannot have a 100 boxes to pour at a time. So balancing the entire foundry is equally important. You can't have a 3-ton furnace and running a 500 by 400 vertical flaskless line trying to produce ductile iron. You can imagine
But
what
you
will
have put the
happen.
right aspect of this activity, that while choosing the process, you have to understand the side or service activities also, like core, metal, your sand. All these has to be matched with the molding machine.
So,
Otherwise,
so
the
these,
mismatch will not
yeah.
give your desired results.
So if you're designing a greenfield foundry, I would advise to start from the molding process first before deciding on any other machines. If you're working with a brownfield foundry where you have already certain facilities, then decide the molding process based on what facilities you have. Don't do it should be a balanced, and you should not get into a mismatch.
Yeah. I have a last question. I think we can say a concluding question. We can say is regarding what is the benefits of high pressure line over the alpha line as a overall. We can say as a process. We already talked a lot about lot of things regarding to high pressure line, but what are the actual benefits people should look when they are somebody has a alpha line and they want to go for a high pressure line? What benefits they can expect from the high pressure line? What are the challenges while they are changing their technology from alpha line to high pressure line? And what are the benefits and what are the disadvantages also they can think about before changing the process, upgrading the process, we can say.
So as I mentioned in between, the primary criteria or the primary advantage of installing, upgrading your process to high pressure is coming from the end product dimensional and weight consistency. Then the surface finish of the component, because if your mold is more compact, the surface finish is better. So if you are able to, if you have the documentation of what is your present process variation in a brownfield, then it will be a much easier decision to make to shift from Jolt Squeeze to high pressure. But if you say that I am able to control Jolt Squeeze components also within 2%, and the high pressure is also going to give 2%, then you may not be able to justify your investment. So I would, so this is from the internal economics. Okay. The external factors which drive the business are the buyers. Today, a buyer would look at who has a better process control or reliability as in comparison. So definitely the first preference would be given to somebody who has got a high pressure. In that also, if I'm making the same casting in a vertical, And in a horizontal, then I would, as a buyer, would give the first preference to somebody who's having a vertical casting, flaskless molding. So we have to understand that for a certain product, what is the best process today, and my existence itself comes from the buyer or the customer. So if I look at a macro level as a business, then I must also look at what is the market expecting. They are expecting somebody who is consistent, reliable, and the quality is not dependent on the person. So this advantage of weight and dimensional and surface finish are the three primary criteria. The second criteria comes is in the volume which you can create, because if I'm a business head, I've got a X and there's a fixed cost of X. In that X, if I can produce Y production, or I can produce 3Y production 3 times, then the scale, economics of scale is something which will change the moment I get into high pressure. So if you have access to market, if a buyer has access to market, buyer has access to increasing the volume, there's working capital available, there's financial capacity, then a high pressure carries the second advantage of being able to convert those opportunities into real business. I think these, once you have these two, the other are smaller areas, also important areas where you are looking at a better working environment. You are looking at, so today we are talking of ESG, environment, social governance. We are looking at so many different factors of operations, where if you don't have a good manufacturing facility, you are not given a good rating, you will not get business. People will not come and work with you. So people will also prefer something which is much more modern and lesser strenuous. So high pressure also gives that advantage of at least giving a much better facility. So these are some of the few advantages which come to me of the cuff, means from my experience. The challenge is today is not having sufficient expertise in process management today in our country. We don't have a good repository. Of course, our education system has nothing to do with high pressure today. Whatever education, I think one of the forums is Dynamic Foundry group, where a lot of repositories being created which can help and support this technology. But as an ecosystem, we don't have much of training available or exposure available to high pressure, and that does not give us a good workforce ready. So technical expertise is missing. Along with technical expertise, the tooling required for high pressure to get the best benefit, that also is not so well developed. It is still, we are far better than what we were 15 years, 20 years ago, but still we have a long way to go when it comes to tooling, which kind of materials to use, how to optimize. So technical challenges, and the third is selection of the machine itself, which we discussed a little while back. There is not enough knowledge or there is not enough transparency in how you can select a good plant. Because if you don't select a good plant, and you may just follow somebody else is doing this, I'll do this, then you have invested in something which can produce 3 times. So of course the capital investment will go up, so your risk will go up. So a good understanding of the project, a good understanding of the economics, the risks, strategizing is one of the challenges which I see today.
Manish, you have been traveling many foundries in India as well as in many foundries abroad also. So what is the difference in India and abroad? The mindset of people in adopting this high pressure machine technology. You see any difference in Indian foundry owners mindset and the mindset of the foundryman in we can say abroad countries?
See, the mindset challenges, I think, lie everywhere. It's the phases of mindset change are different. The phases could be different. So because I am also part of a lot of philosophical and psychological understanding of mindset today. For me, whether it is in Europe or in India or in America, the mindset challenges are similar. The environment plays a very big role. As I said, if you go to Germany or you go to Switzerland, your vocational education and your practical training ecosystem and the culture building, the experiential learning ecosystem, this allows a shift in the mindset of people working. And so this is at a very root level. This is one part. When it comes to secrecy, when it comes to not cooperating, not collaborating, I think we are humans all over the world are similar in different, whether it is in India or overseas. I don't think we are very different.
So in Europe and other countries abroad, we are seeing high pressures are increasing as compared to India, or is it the same scenario?
No, in Europe, the Jolt Squeeze machines have disappeared because the laws, so the one of the first fundamental
Is noise? Because of
noise. So anything above 85 dB is not permitted. Second, you cannot work in unsafe condition. So if you take these two parameters, Jolt Squeeze machines will be out of the country.
So
If you
slowly
enforce
India,
this law.
so slowly Indians are also moving to the same stage, or you are saying any change in the mindset or a change in the decision
It is
making
not. It is
last
not.
10 years?
It is not because of these two reasons. It is because of the economics. More is more driven by the economy rather than by unless. So two things I think drive this selection. One is the economics, which is for every business is important, and second is the buyer themselves. So when the buyer says that you have to follow these norms or you have to
Customer
comply,
specific requirement
customer specific requirement. When the customer says that you have to comply to these norms, then automatically you'll have to remove the processes which will not
they are asking for the perfect weight, they're asking for good surface finish, they're asking for less mismatch, and they you don't have any other choice than opting
asking for safety.
for the safety.
They're also,
yeah.
Yes, they're
And environmental aspect.
Yes, so
you don't have any choice, another option than opting for the high pressure line.
Means transition has to happen. You have to understand how you will transit, and transition is always a challenge.
Okay, thank you, Manish. I think you are given a lot of good knowledge and good information to all of us regarding the high pressure line. What are the benefits, advantages, disadvantages? What are the challenges, and some we can say misconception has been also is there regarding high pressure. That is also I think clear in minds of most of the listeners and the participants. So thank you very much for your kind support. You have been always there with us with the dynamic group and with the Indian funding industry for their betterment. And I hope the association will continue in the future as well. So thank you very much for your nice time in today's session. And I hope that it will help the countryman to decide and take the benefit of it. Thank you very much.
Thank you so much. Thank you so much.
Thank you, sir. Thank you.
Yeah.
Bye.